Okay, so now that we know the chain rule, we can talk about derivatives of other special functions, like the function e to the x. So if you have f of x equals e to the x, then the derivative of e to the x is e to the x. It's its own derivative. There's a terrible math joke about differentiating a function down to 0, but e to the x is unable to do that because it's always just e to the x. But what if there was something, what if it was like a chain rule? So I also have another, so we're going to say, also, what if you had like g of x equals e to the u, where u equals some function? So I'm going to say u equals some function like f of x. That means you have to do the chain rule. So the derivative of e to something besides x would be like e to the u, but then u would be your inside function, so you have to multiply by u prime. Which is really just the chain rule. So obviously they're not just going to give you e to the x all the time, because that would be too easy. So usually there's going to be some function up there. And so this is where you get to decide if you like u substitution or you don't like u substitution. So I'll do it both ways on this first one and show you. I, as I normally say, don't really like u, haha, because it's my favorite joke to say, but mostly because I don't need to use substitution. So if I did u substitution, u would be sine of x here. So if you really wanted to, you could say u equals sine of x, so then u prime equals cosine of x. So if you like u substitution, you could rewrite this problem as e to the u. So the derivative of this would be e to the u times u prime. And the reason I don't like u substitution is because I can do it without u. But now if you do this, you just plug u back in. So this becomes e to the sine of x, stop it Nolan, times u prime, which is cosine of x. And I'm going to show you what I mean by this. Boys, you better walk away from me right now. So that's u substitution. I'm going to show you I don't have room in the same box to do it without u substitution, but I'll do it on the second one and see if that makes, so you can decide what you like, okay? So what I do when I do this is I kind of notice that this is what's up in the u part, or that's the inside function. So I leave it alone, so e to the 2x plus 3 times the derivative of the inside. The derivative of 2x plus 3 is just 2. And you can't really do anything with that. Maybe I would put the 2 in front because I think it looks better. But that's it. So if you like the u substitution, you can do it. But for me, it's not really necessary. Boys, I am recording. Move to the back of the room if you're going to play that with sound. So now look at the next one. 3e to the 2x. You might think, do I need the product rule on this? I hope you say the answer is no, because 3 is just a coefficient. So the 3 is just going to stay there. And then e to the 2x is going to be e to the 2x. But then the derivative of 2x would be times 2. And if you don't like to rewrite things, maybe you just want to say, well, I already know 3 times 2 is 6. So 6e to the 2x is my answer. Huh? What about the next one? Do I need the product rule on this one? Yes is the answer, because this is just a 3, so you don't need a product rule. But this is an entire function times an entire function. So the product rule says I would take the derivative of this, which is just 2, leave e to the 3x alone, plus, now I'm going to leave the 2x plus 3 alone, and the derivative of e to the 3x would be 3e to the 3x. Because e to the 3x and then the derivative of 3. I don't know what you can do with this. To me, if you put parentheses around this, you could just leave it. But, you know, they're always going to simplify it. I could distribute this. So 2 times 3 would be 6x e to the 3x. And then this would be plus 9e to the 3x. So I can't do anything with this middle term because it has an x e to the 3x. But 9e to the 3x and 2e to the 3x, I think would just be 11. 11e to the 3x plus 6xe to the 3x. Maybe you could factor out an e to the 3x if you want. I don't know. I'm leaving it. Look at the next one. Do I need the product rule? Yes. So I would get...
How many minutes in its Nolan's soccer game?
He has practice at 5:30, so 1 hour and a half.
I think I have it too.
Okay. So the product rule says the derivative of this, which is 2x times e to the 2x, leave it alone, plus leave the x squared alone, and then that would be e to the 2x times 2, but I like to put the 2 in front. So thinking about those circuits, they usually factor things out, right? So I'm going to do that on this one. What can I factor out of this? I can factor out a 2, an x, and an e to the 2x. 2x e to the 2x. That's all of this, right? So that would just be 1 plus x. Because I have x squared here. I took out the 2. Yeah. So thinking ahead to like maybe solving these equal to 0, like that would be a good thing to factor. I'm going to leave that as my derivative. Oh, it's Emma's favorite with the square root. The first thing I'm going to write on this one is I'm going to rewrite this as e to the 2x minus 6 all to the 1/2 power, which means if we remember our rules of exponents, I don't even think that this becomes very complicated, because when I have a power to a power, don't I just multiply those exponents? So this is one of those when I think we could simplify first. If I take 1/2 times 2x minus 6, isn't that just x minus 3? Like that would be my u here. Yeah. Parker, please stop. So when I take the derivative now, that would just be e to the x minus 3 times the derivative of x minus 3 is just 1. So that turned out way better than I planned for it to be. Yeah? I think so. All right, I'm only doing one more page, because then the next page is how to use the calculator. So bring your calculator to class. What about this one? Oh my gosh, I think I need the quotient rule. So the derivative of the top would be 5e to the 5x times the bottom, which is 3x squared, minus the derivative of the bottom would be 6x times the derivative of the top, which is e to the 5x. No, not the derivative of the top, sorry. Over the denominator squared would be 9x to the 4th. So you have to know the quotient rule. And now let's just see if we can clean it up in e. Again, we could multiply there. We could factor out an e to the 5x if you want. Okay, I've just got to write it out now. I can't do it. 15x squared e to the 5x minus 6x e to the 5x all over 9x to the 4th. Stop. Sit down and don't move. So on the top, I could factor out a 3x e to the 5x. And I would be left with 5x minus 2 over 9x to the 4th. And so I'm doing that because now I could simplify. Like I could cross out this x with one of these x's. Nolan, I'm not even joking right now. You got to stop. Put your hands back and stop.
I'm sitting down.
If you touch my computer again, you're grounded until you're 20 seconds.
Good. I'll be charging your own stuff.
Also, I could cross out a 3 with a 9. So I think the simplified answer here would be e to the 5x times 5x minus 2 all over 3x cubed. Okay, one more rule. We're almost done if my children survive. ln, natural logarithm is like f of x equals ln of x. And the derivative of that, f prime of x, is 1 over x.
Mom, can I have some of these chocolates? No.
To be quiet. But just like if you have ln of something besides x, like ln of u, you have to do the chain rule, which is going to be 1 over u times u prime, or I like to think about it as u prime over u. So if I practice a couple of these and then I'll stop, this is like your u. So again, I don't really do the u prime, but what I do is the denominator is always just what is inside the function. So that's 2x minus 3. And then the top is the derivative of this. So the derivative of 2x minus 3 is just 2. You may not cancel out this 2 with this 2 because it's addition, which means that's your derivative. So u prime over u. So think about this one. The numerator is just the derivative of the inside. So that's 6x plus 2. The denominator is 3x squared plus 2x because that's your u on the bottom, u prime on the top. You can't simplify anything there. You can't cancel anything out. So that's your answer. But then what if they give you like ln of cosine? That's exciting. Still, same idea. The denominator is just the inside function, which is cosine, but the numerator is the derivative of cosine, which is negative sine. And then I don't want you to leave it as negative sine over cosine because sine over cosine is just tangent. So the answer here is really negative tangent. How fantastic is that? And now this one looks terrible, doesn't it? This one is like ln parenthesis 2x minus 4 all to the 1/2 power. And we can't just take 1/2 of 2 and 4 on this one because the e had the exponent on this one. So this one, the denominator would be the square root of 2x minus 4, or 2x minus 4 to the 1/2. The numerator will be the derivative of this. So that would be 1/2 times 2x minus 4 to the negative 1/2 times the derivative of the inside, which is 2. So this one requires some simplifying. The good news is the 1/2 and the 2 cancel out. Nolan, sit down. This is a negative exponent, so we can go on the bottom. So I think there's nothing left on the top. And on the bottom, I have 2x minus 4 square root twice, right? And the square root of 2x minus 4, and bring this one down, the square root of 2x minus 4 is just 1 over 2x minus 4, which just turns out really nice, in my opinion. So we'll talk about this more tomorrow. Right now.